All right, welcome to our talk on irrigation resources and sensor systems available in Tennessee. This is part of the water management tour at the Mile and No-Till Field Day. And we're standing at a site where we'll have two activities going on this year. One directly behind me will be a sensor comparison site. And then further on behind me is a soybean irrigation experiment that we'll take a look at. The purpose of the sensor comparison sites is to help us learn how to better optimally irrigate for the best yield possible with a minimum amount of water. And this site is really designed to allow you to be familiar with some of the systems that are available to you before making that decision, so you can make a good decision about investing in soil water sensors. Some of the purpose of what you'll see in the sensor comparison site is we'll get a look at some of the equipment that's being used, how it's going to be installed, and then we'll show you a website where you can access in real time what we're seeing. And so you can see how these soybeans that we're at are progressing, what the soil moisture is like, what the irrigation decisions are like. And I want to make clear that we've really kind of limited this. There's a lot of sensor systems available that you could invest in, but we've limited this to systems that are being supported by either UT or companies in Tennessee, where you will get support to help you know how to install them, how to interpret them, and how to use them. So again, we'll look at some more of this later, but for now I want to switch gears a little bit and look further behind us to the soybean experiment. The purpose of this experiment is to get us a little more familiar with variable rate irrigation, how an irrigation system can be used to apply different amounts of water to different parts of a field, when we should be initiating irrigation in soybeans by growth stage. And there's other factors: maturity group, soil type, the weather patterns of a particular year. All those things go into making an irrigation decision. These are things we're learning from this experiment. Also, since we have some of the sensor systems in these fields, as we're doing these experiments, we'll be looking at trigger points to start irrigation based on those sensors. I also want to let you know and clue you into other resources we have, because we've been doing experiments like this for 15 years. So we're trying to, we are putting those into publications where we can look at irrigation recommendations for row crops that have been developed right here in Tennessee. With that, let's take a closer look at the sites.
I'm Jeremy McKay with Mid-South Farmers Cooperative out of Jackson, Tennessee. I'm here installing a Aqua moisture sensor to put in comparison with the other ones here. Basically all you do is auger down 4 foot. We've got a 4-foot probe here. Every 4 inches it reads moisture. Try to find a spot in between plants. It reads 6 inches out. That way you can also tell the root depth as it takes up moisture. So basically all you're going to do is auger the hole out, sift your dirt, come up with a solution. Kind of like pancake batter, I guess. That's the kind of solution you're wanting. Pour it in the hole. Push your probe down in. Sometimes you may have to step on it to get it to go. And you want the solution to come up all the way around it. That way you've got a good tight seal. And then all you do is plug it up to our monitor here. And it sends data every, I think, 30 seconds to the web portal, and you can go on there and monitor the way your moisture is going up and down the probes.
I'm here representing Matt White today with Adventure Mid-South and their soil water sensing system called Precision King. Maybe the first and most important thing is the sensor itself, which we have here soaking in water. It's pretty important to soak these in water. This is called a watermark sensor. It measures matrix potential, or sometimes it's easier to think about soil tension. In other words, the drier it gets, the more tension there is for the soil or the plant to pull water away from the soil, and this will be measuring that. So once we've soaked them, good. It helps them get a good start and good contact in the soil. Again, good contact's important, so we use a slide hammer to make a pretty tight fitting hole for the sensor. It needs good contact for water to flow back and forth from it. And what the slide hammer does is help you get down into the soil pretty easily and actually get your auger or instrument back out. And you can see it's pulled up a core of soil, leaving room to put the sensor in. And so far we've put in a 6-inch, an 18-inch, and we're about to put in a 30-inch. So we would just push this down in and seat it pretty well. I'll have to dig that a little deeper later, but and then each wire would go into the logger box and be connected. And once these three are connected, you'd hook up the battery, and then you have a solar panel that will keep the system charged, the battery charged inside here to keep this running. All the communication is done via cell modem, and so all this will be real time on the cloud for you to view. And in a little later episode of this talk, we'll be showing you how to reach that site and how to look at what's going on here.
Good morning, everyone. Welcome to Marlin No-Till, actually Marlin Virtual No-Till Day. My name is Avat Shekoofa, and I'm a crop physiologist with the University of Tennessee. I'm located in West Tennessee Research and Education Center. Today, I will talk about soil moisture, soil water, soil moisture sensors in soybean field. And this is going to be part of our water management tour, talking about sensor-based irrigation, why we should use sensors, how they can help. The main goal is to be able to use less water while we still have good, high, maximized yield for soybean in West Tennessee. They are different variety of this soil moisture sensors that you can try, but the point is whichever you prefer, what type that exactly you're going to use, it doesn't matter. What is important is getting the information about soil and the farmland and the area that you are planting your plant. That's what we need. So here I'm standing close to one of my stations from Meter Group, and this station actually has the rain gauge, digital rain gauge, that is connected through a port to the main box of this system that has all the ports that connect us to the to the soil moisture, soil water content, different sensors that we have in the soil in depth 6 and depth 24, and each one of these are doing giving us information about soil water content and soil water tension, and how the soil is holding water and how plant can uptake that water. So at what rate the soil volumetric water or soil water potential is, it's very important for us to know that, because when the plant is growing, the root depth is changing, the root zone is kind of changing, so the amount of that water uptake and the water potential for sure is going to change, and you're going to see different reading from the sensor that you receive. The cool thing about this one is this system is using the cloud, and so you can use internet. With your internet access, you can read the information of your loggers, your sensors, and you can use the app, Zentra Cloud app, and just like the way I do right now, I'm checking the name of this logger with the name I see here on my Zentra Cloud app, and I synchronize it. So now at the moment I have a clear access to the amount of rainfall that this rain gauge received in the past 24 hours. And I do have access to water content. In the first one, as I mentioned, it's in 6-inch, and the other one in 24 inches. And I can see the like the bar or a kilopascal rate of each one of these depths. So overall, I can see at what situation my field is at the moment. So we we are looking at the rate of water availability for soybean, and when that rate is lower than field capacity, and we see through this soil water content, we can apply or initiate irrigation, which that can be sort of correlated to our soybean growth stages. So we need to know what growth stage it's better to initiate this irrigation and what amount of water we're going to put there to maximize the yield.
One place you can go to learn more about irrigation resources and sensor systems available in Tennessee is UT's Biosystems Engineering irrigation website. Here you'll find publications that are based on research that was actually done in Tennessee. For instance, soybean irrigation recommendations from these publications are based on 14 research trials from 2013 to 2020, plus monitoring sites out in producers' fields. What this publication will really do, I think, is give you some perspective on how to deal with the variability that goes into making a good irrigation system, such as variability in crop water use, soil type, rainfall pattern, and what are the critical growth stages. Some information you'll find in these publications that are pretty direct is when to start irrigation. For deep silt-loam soil and soybeans, we often could wait to R5 before needing to irrigate. But in sandy soils, we need to usually start earlier, R1 or R3. How much water to apply in soybeans? Only about an inch per week is needed around R1. But we did make some notes from some of our field experience. It says, hey, if you have sandy soils on a late planted beans with no residue cover, you could have a lot of soil surface evaporation and need a lot more water than that because it's evaporating as fast as you're putting it on. Also, after R3 in soybeans, when the soil water use levels out, you'll need to apply about 1.5 inches between a combination of rainfall and irrigation. And again, water use can vary from year to year, but that's an average. Also, when you go to apply that amount of water, you need 1.5 inches in a week. Remember that you can't put it on all at once, so you'll have runoff. So reduce it according to the slope of your ground. And also when to stop soybean irrigation. We found the R6 is a good time to stop, as long as you have enough water to finish off the crop. And sometimes that's a little harder to do in sandy soil, so you might need to go to R6. Yield reductions did occur, and that mostly did in soybeans when we were on silt-loam soils with poor drainage. We lost yield when irrigating in the late vegetative stages and early reproductive stages. Also, at the end, from R6 to R7, extra water at that time seemed to hurt us somewhat. So we didn't see this response in well-drained soils. So again, that just kind of points to the fact that we got to watch we don't put too much water on soybeans. Similarly, cotton was based on research trials from 2006 to 2020. And again, the recommendations are a little bit different. When to start irrigation, we found that in deep silt-loam soils with cotton, we could wait most years to after full bloom. Whereas sandy soils, we almost always needed to get on at square. Again, there's exceptions to this when rainfall patterns vary. How much water to apply to cotton? It uses more water than soybeans, so our average is 1.65 inches. And again, we'd be wanting to apply that after bloom in silt-loam soils and after square in sandy soils. The traditional place to stop irrigation in cotton is cracked bowl, and we do agree with that. Often in a silt-loam soil, there's sufficient moisture and rainfall to finish the bowl development after cracked bowl. But in sands, we found that sometimes it really did help to put some extra water on after crack bowl. Yield reductions, yes, we had yield reductions in silt-loam soils when we irrigated at a high rate during square, and this occurred even in well-drained soil. So it doesn't seem to be necessarily as much a matter of how much oxygen is in the soil as it is promoting vegetative growth in a perennial when we really want to be promoting reproductive growth. Another thing we were able to put in these publications from the work we did is soil moisture sensor information. What's the good range for different sensors and soil types. And so if you choose, say, the MPS2 sensor and soybeans, you could go down and find I'm in a silty soil and then get the range for the different growth stages that is ideal to keep your soil moisture in for production of that crop. In addition to publications, this website also gives us access to the sensor comparison sites. You saw us installing at Milan. If you click on the Access Real-Time Sensor Demonstration sites, it'll take you to this web page. This web page, you can see the 3 sensor systems there in front of the center pivot where we're comparing those. And again, I just wanted to remind us that these are the sensor systems that are being supported in Tennessee. So if you invest in these, you'll have someone who could help you install them, help you interpret them, and so that can be a very important factor. If you move down further on this page, you'll see where those sensor sites are located. We have 3 of them. You can see the one there at Milan in Gibson County. That's in soybeans. You can see the one in Fayette and Hardeman County, which is in corn. And we're looking for one on the Dyer Lake County border there where will be wheat beans. This site also shows you the 3 systems that are available and supported in Tennessee: Zentra Cloud, Aqua Spy, and Precision King. And it gives at the very bottom of the page the contact information to talk to someone about those systems. Also, if you click on any of the pictures or the text for the name of the system, and then you'll go to that website, and then right below those pictures for each one, you'll see a username and password. If you enter that, you'll be able to get in and look at these systems real time. Again, I just want to remind you, we're doing this back at the end of June, and you're going to be looking at this end of July. So what I'll show you here in the future, in the next couple slides, is not really what's happening right now, but you can go and see what's actually happening in real time if you select a system and put in the username and password. So here's the Zentra Cloud system on June 24th at the Milan Rec soybeans. You can see we have 3 depths of sensors with the different colored lines. They're all in or above the green zone, and the green means that's where there's easily available water to grow this crop. Above that, it's too wet, either from saturation or the possibility of losing irrigation water from drainage. And below that is where it starts to become a little stressful for the plant to take water away. If you get below that green zone, for the plant to take water away from the soil. And again, that doesn't mean a yield disaster if you go below that, but it does indicate if all the sensors are below that, there's potential to start to lose yield. Also, if you see the gray bars to the bottom, that's the rain gauge, so you can see irrigation and rainfall events. Let's move to the Aqua Spy system, again in soybeans at Milan. And as you look at the main graph to the right, you can see that there's a green band. That's the range we think we want to be in to promote optimum yield. You see at the beginning, when it was slurried in, it drained quickly. And then those rainfall events, again, bring it up high and it drains back down. So in addition to that, if you want to, that's a summary of 10 sensors. If you want to see the individual sensors, you go up on the bar above that and hit moisture and see all 10 sensors and what's happening at each depth. More to the lower left, you can see the root development of that crop. And then also, if you just want to look at one thing and say, where am I? There's a fuel gauge at the very bottom left. And then our final system is the Precision King system. And there you can see 3 graphs that you'd find if you got into the Milan site. One where you can see the individual readings and the weightings for those readings. The middle one where you can see the summary of those readings by those weightings and how close it's coming to the trigger line that you set. A warning to not go beyond that and not expect to have yield loss. And then finally, if you want to look at the individual sensors, are over on the far right. And just to end, I'll throw back those websites so you can get to the irrigation management page and find the publications. Or you could go directly to that sensor comparison site if you want to look at what's happening in between the sensor systems. Glad to spend a little time with you. Have a great day.
Today we're going to talk about variable rate irrigation and irrigation scheduling in soybean production here in West Tennessee. Before getting there, I want you to have a quick look at this slide showing the irrigation acreages in the United States. Overall, we have very low percentage of areas that they are under irrigation. Around 6% of soybean production in the entire United States of America is irrigated. And in West Tennessee, we have more than almost 95% of our soybean fields are under rain-fed conditions and no irrigation. But moving to next slide, you will see that this irrigation patterns like in the state of Tennessee as well as West Tennessee is increasing. This graph on x-axis is showing the years of since 1930 to 2010, and the amount of land under irrigation in West Tennessee or in Tennessee, and they have the same pattern of increasing in West or in the entire state irrigation using different irrigation systems and irrigation scheduling. Why this is important? Why it's important? Why irrigation? So the point is, when you want to manage a field, there are different options that you can do to do a better management. But when it comes to yield production and water availability, we do not have too many choices to make. What we can do is do better or set up irrigation system and do the irrigation scheduling. And the other case is we can use a variety selection due to the environmental conditions. What type of varieties, cultivars are better for here than the other locations? If not irrigation, that may help with our production. But back to irrigation and issues that we have and questions that we have about irrigation. So most likely we're gonna hear that what are the best timing to start irrigation this cropland, this area versus the other place? When is the best timing to terminate irrigation here versus there? So today I am gonna share with you some information about the latest growth stages of soybean that we can start irrigation but still get good benefit out of it. Let's look at this slide, and this slide actually is showing soybean growth stages, but only reproductive part of growth stage, because we are going to talk about this part and we're going to find some correlation between this and irrigation timing. So the growth stages, reproductive growth stages are, you see, R1 to R2 bloom stage up to full seed as R6 and maturity. So with that, I am going to tell you why we decided to speak about reproductive part, not vegetative, because of previous studies back in 2014, 15, and 16. Different studies for irrigation scheduling was done in, they were working on it, and they finished and wrapped up these studies on variable irrigation system in West Tennessee, which if you look at these tables, you can see in 2014 there were application of vegetative stages and initiation in different vegetative stages and reproductive. So in 2015 the same pattern, and 2016, but they couldn't find any significant changes and impact in irrigation earlier in vegetative stages. So based on that previous result, we found out we better focus on reproductive stages for initiation. For that reason, our field trials are covering only initiation at 3 different stages: R1, R3, and R5. And as I mentioned, termination of this irrigation system in the past were tested, and R6 was the best timing to terminate irrigation. To compare this with an actual situation of rainfall, we assigned a few plots to only rainfall, no extra irrigation needed, to be able to compare each one of these scenarios with rain-fed condition. So here I just left a few slides here to show you our setup and our soybean line, which was one of the late 4 soybean pioneer soybean line planted in Milan Research Center in 2017, and then 2017 and 19 here year, while we covered 3 years, 17, 18, and 2019. This slide is showing the structure of our soil moisture sensors, soil water sensors that we use in the field. And so we use two different depths, 6 and 24, and we adjusted a few different stations and sensors in our soybean replicated plot in myelin each year to be able to understand and to see the soil water tension and how fast or quick plants are going to uptake the water, and how drier environment can impact on this soil water tension and make it difficult for a plant to uptake that water. So at what stage we need to initiate irrigation because of the amount of soil water and then because of the tension that we see in the soil, when is the best timing to do? And see, before going to the result of this study, I want you to look at the environmental impact of rainfall and how that impacted our irrigation scheduling. So 2017 and 2019, we had plenty of rainfall between late May to late August, while we had the best situation in 2018 for irrigation, because we didn't have good distribution of rainfall in 2018 during June to August, that plants are experiencing more drought or more high temperature. Looking at this slide and looking at the table, you'll see in 2018 we had more irrigation amount of water applied in each plot. So with that, let's move on to our result. So with high amount of rainfall and having our field most of the time in field capacity, so of course adding water did not meet the goal that we had in our study. So we didn't see very high impact of irrigation on our soybean production, while still R5, R6 irrigation start at R5 and terminated at R6 had the best result among our treatment. And while there were no significant changes between that application and rain-fed. How about 2018? 2018, we had significantly higher yield in all of our irrigation plots versus our rain-fed plot, which again, R5, R6 is going to be our best scenario, with less amount of irrigation, less amount of water, still have higher or maximize the yield with this amount. So still supporting our recommendation of R5, R6. What about 2019? 2019, still we had R5, R6 at highest yield amount with almost 3% higher yield than rain-fed, but we couldn't find statistically significant differences. Again, you remember how much rainfall we had in 2019 and the field capacity situation. So we did not see much changes of this amount of irrigation that we applied. But with all of this saying and different years of study, R5, R6 is the best recommendation. Seems like you apply less amount of water, but you still have better yield and quality of soybean. So what happened during 2018, to emphasize that rainfall thing, I just created this table to show you May to August 2017 and 19, how much rainfall we had, and compare that to the amount of rainfall we had in 2018. With this saying, it is clear that the type of soil that we have, the amount of rainfall that we have, and plant growth stages can change that the impact of irrigation and scheduling of that irrigation. Our silt loam soil and the amount of rainfall that we receive in these years help with recommending that R5, R6 will help with better soybean production. But this shows the environmental impact clearly. What we are doing for 2020, as I mentioned in previous studies, we mostly use maturity groups 4 of soybean, late 4. So this year, we already planted 2 different maturity groups, including maturity group 3 and 5 under variable rate. And we are going to apply the zero rainfall, no rainfall, just rain-fed, and then selection between R1 or R3 based on the wet or dry year, and then R5 irrigation initiation. With this, we can see and we can determine this how soybean, different growth stages of different maturity group of soybean can change the water needs and the amount of water that they need to receive during growing season, and can show us for each one of growth maturity group what is the best timing of initiating of irrigation. And the other thing is, with comparison between these maturity group soybean 3, 5, 4 and 5, we can find out how much rainfall and how much irrigation, the extra water that we apply, is needed to improve yield of each one of these maturity group soybeans. So with this, I would like to thank our funding and support from United Soybean Board and all the student and other technician in Malin that they help us with making sure the irrigation system is working and everything, all the support that we receive from Malin crew for this study. Thank you.